National Electrical Code, or NEC, is a comprehensive set of standards designed to ensure the safe installation of electrical wiring and equipment. Its primary focus is on minimizing fire and shock hazards associated with electricity. It covers a wide range of topics related to electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a design manual, but rather a set of rules and regulations that must be followed to ensure electrical safety. It is updated every 3 years by the National Fire Protection Association, or NFPA, to reflect changes in technology and best practices. The NEC is adopted by many state and local jurisdictions in the United States, and it is also used as a reference document in other countries. It is an essential resource for electricians, electrical contractors, inspectors, and engineers who work with electrical systems. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 contains general requirements that apply to all electrical installations. Chapter 2 covers wiring and protection, including topics such as wiring methods, conductor ampacity, overcurrent protection, and grounding. Chapter 3 addresses wiring methods and materials such as conduit, cables, and raceways. Chapter 4 covers equipment for general use, including switches, receptacles, and lighting fixtures. Chapter 5 addresses special occupancies such as hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment such as electric signs, elevators, and welders. Chapter 7 covers special conditions such as emergency systems, fire alarm systems, and communication systems. Chapter 8 covers communication systems such as telephone, radio, and television. Chapter 9 contains tables and examples to assist in applying the code. When working with electrical systems, it is important to consult the latest edition of the NEC and to follow all applicable requirements. It is also important to be aware of any local amendments or interpretations of the code. The NEC is a complex document and it can be challenging to understand and apply. However, it is an essential resource for anyone who works with electrical systems. The information you are seeking, specifically details about tenpenny nails, is not found within the NEC. The NEC focuses on electrical safety and proper wiring techniques, not on general construction materials like nails. Information about nail sizes, types, and appropriate uses would typically be found in building codes or construction standards, not in the National Electrical Code. These codes and standards are developed and maintained by different organizations than the NFPA, which publishes the NEC. Building codes address structural integrity and safety aspects of buildings, including the types of fasteners used in construction. To find information about tenpenny nails, you would need to consult building codes applicable to the specific location where the construction is taking place. These codes often specify the types and sizes of nails required for different construction applications such as framing, sheathing, and roofing. Additionally, you could refer to construction industry standards and best practices for guidance on selecting the appropriate nails for a particular project. These resources often provide detailed information about nail dimensions, materials, and load-bearing capabilities. In summary, while the NEC is a valuable resource for electrical safety information, it does not cover topics related to general construction materials like nails. For information about tenpenny nails, you should consult building codes and construction standards. These resources will provide you with the information you need to select the appropriate nails for your construction project. The NEC is a critical document for electrical work, addressing a wide array of topics to ensure safety. Firstly, it details proper grounding techniques, essential for preventing electrical shock and ensuring that fault currents can safely return to the source. This involves understanding the role of grounding electrodes, grounding conductors, and bonding jumpers, all of which contribute to a low impedance path for fault currents. Secondly, the NEC specifies requirements for overcurrent protection, such as circuit breakers and fuses. These devices are designed to interrupt the flow of electricity when a fault or overload condition occurs, preventing damage to equipment and reducing the risk of fire. The NEC provides guidance on selecting the appropriate size and type of overcurrent protection for different circuits and applications. Thirdly, the NEC addresses wiring methods and materials, including the types of conductors, cables, and raceways that are permitted for different installations. It specifies the ampacity of conductors, which is the maximum amount of current that a conductor can safely carry, as well as the requirements for protecting conductors from physical damage and environmental factors. Fourthly, the NEC covers equipment installation, including the proper mounting, wiring, and grounding of electrical equipment such as switches, receptacles, lighting fixtures, and appliances. It specifies the clearances required around electrical equipment to allow for safe operation and maintenance, and it provides guidance on selecting equipment that is suitable for the intended environment. Fifthly, the NEC addresses special occupancies such as hazardous locations, healthcare facilities, and recreational vehicles. These occupancies have unique electrical requirements due to the increased risk of fire, explosion, or electric shock. The NEC provides specific guidance on designing and installing electrical systems in these locations to ensure safety. Sixthly, the NEC covers special equipment such as electric signs, elevators, and welders. These types of equipment have unique electrical characteristics and require special considerations to ensure safe operation. The NEC provides specific guidance on wiring, grounding, and protecting these types of equipment. Seventhly, the NEC addresses special conditions such as emergency systems, fire alarm systems, and communication systems. These systems are critical for ensuring safety and communication during emergencies. The NEC provides specific guidance on designing and installing these systems to ensure that they operate reliably when needed. Eighthly, the NEC covers communication systems such as telephone, radio, and television. While these systems typically operate at low voltages, they can still pose safety hazards if not properly installed and maintained. The NEC provides guidance on wiring, grounding, and protecting these systems to ensure safety. Ninthly, the NEC provides tables and examples to assist in applying the code. These tables and examples provide practical guidance on sizing conductors, selecting overcurrent protection, and calculating voltage drop. They are valuable resources for electricians and electrical contractors who are working in the field. Tenthly, it's important to remember that the NEC is a living document that is updated every 3 years. It is essential to stay up to date with the latest edition of the code to ensure that you are following the most current safety standards. In addition to the specific topics mentioned above, the NEC also addresses a number of other important issues related to electrical safety. These include arc flash hazards, surge protection, and energy efficiency. Arc flash hazards are a serious concern in electrical work, as they can cause severe burns and other injuries. The NEC requires employers to perform arc flash hazard assessment and to provide employees with appropriate personal protective equipment. Surge protection is important for protecting sensitive electronic equipment from damage caused by voltage surges. The NEC requires surge protective devices to be installed in certain locations to protect equipment from these surges. Energy efficiency is becoming increasingly important as energy costs rise and concerns about climate change grow. The NEC includes provisions to promote energy efficiency in electrical systems, such as requiring the use of energy-efficient lighting and equipment. The NEC also provides guidance on the proper use of electrical equipment. For example, it specifies the requirements for using extension cords and surge protectors. Extension cords should only be used temporarily and should not be overloaded. Surge protectors should be used to protect sensitive electronic equipment from voltage surges. The NEC also addresses the issue of electrical safety in the home. It provides guidance on the proper installation and use of electrical appliances, lighting fixtures, and wiring. Homeowners should be aware of the potential hazards of electricity and should take steps to protect themselves and their families from electrical shock and fire. Some common electrical safety tips for homeowners include never overloading electrical circuits, never using damaged electrical cords, and never touching electrical equipment with wet hands. It is also important to have your home's electrical system inspected regularly by a qualified electrician. The NEC is a complex and comprehensive document, but it is an essential resource for anyone who works with electrical systems. By following the requirements of the NEC, you can help to ensure the safety of yourself, your employees, and the public. Remember to always consult the latest edition of the NEC and to follow all applicable requirements. The NEC structure involves several key components that facilitate its use and understanding. Firstly, the code is divided into chapters, which group together related topics. For instance, Chapter 2 focuses on wiring and protection, while Chapter 3 deals with wiring methods and materials. This organization allows users to quickly locate the relevant sections for their specific needs. Secondly, within each chapter, articles provide more detailed information on specific subjects. For example, within Chapter 2, there might be articles on overcurrent protection, grounding, or wiring methods. These articles break down the broader topic into more manageable segments. Thirdly, each article is further divided into sections, which present the specific requirements and regulations. These sections are the most granular level of the code and contain the exact rules that must be followed. Fourthly, tables and examples are integrated throughout the NEC to provide practical guidance and clarification. These resources help users apply the code correctly by illustrating how the rules work in different scenarios. For example, tables provide information on conductor ampacity, conduit fill, and box fill, while examples demonstrate how to calculate voltage drop or size over current protection devices. Fifthly, annexes are included at the end of the NEC to offer supplementary information and recommendations. These annexes are not part of the enforceable code but provide valuable insights and best practices. For instance, annexes might cover topics such as energy management, wiring practices, or recommended tightening torques for electrical connections. This structured approach ensures that the NEC is both comprehensive and user-friendly. By organizing the information into chapters, articles, and sections, the code makes it easier for users to find the specific requirements they need. The inclusion of tables, examples, and annexes further enhances the code's practicality and usefulness. Remember that the NEC is not a static document. It is updated every 3 years to reflect changes in technology, best practices, and safety standards. It is crucial to use the latest edition of the NEC to ensure that you are following the most current requirements. In addition to understanding the structure of the NEC, it is also important to be familiar with the key definitions and terminology used throughout the code. The NEC contains a comprehensive glossary of terms that are essential for understanding the code's requirements. Some of the most important definitions include ampacity, which is the current carrying capacity of a conductor, overcurrent, which is any current in excess of the rated current of equipment or conductors, and grounding, which is the connection of electrical equipment to the earth to provide a low impedance path for fault currents. By understanding these key definitions, you can better interpret and apply the requirements of the NEC. The NEC also relies on a system of symbols and abbreviations to convey information concisely. These symbols and abbreviations are used throughout the code to represent different types of equipment, wiring methods, and other electrical components. It is important to be familiar with these symbols and abbreviations to understand the code's diagrams and specifications. For example, a circle with a line through it represents a receptacle, while a triangle represents a ground connection. By learning these symbols and abbreviations, you can more easily navigate the NEC and interpret its technical information. The NEC provides a framework for safe electrical installations, but it is important to remember that it is not a substitute for sound engineering judgment and professional experience. The NEC sets minimum requirements for electrical safety, but it is always advisable to exceed these requirements whenever possible. For example, using larger conductors than required by the NEC can reduce voltage drop and improve energy efficiency. Similarly, using higher quality equipment can improve reliability and reduce the risk of failure. It is also important to consider the specific conditions of the installation when applying the NEC. For example, In corrosive environments, it may be necessary to use special corrosion-resistant materials to protect electrical equipment from damage. By exercising sound engineering judgment and considering the specific conditions of the installation, you can ensure that the electrical system is safe, reliable, and efficient. The NEC is a valuable resource for anyone who works with electrical systems, but it is not the only resource that you should consult. Other important resources include manufacturers' instructions, industry standards, and local codes and regulations. Manufacturers' instructions provide specific guidance on the proper installation and use of electrical equipment. These instructions should always be followed carefully to ensure that the equipment is installed correctly and operates safely. Industry standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI, provide additional guidance on electrical design and installation practices. Local codes and regulations may impose additional requirements beyond those specified in the NEC. It is important to be aware of these local requirements and to comply with them. By consulting all available resources and staying up to date on the latest codes and standards, you can ensure that your electrical work is safe, compliant, and of the highest quality.